I'm going to talk about stem and leaf plots. That's what we went over today. A stem and leaf plot is a way of organizing data in a really compact way that you can see all the data at once and organize it really easily. Stem and leaf plots are very useful. We're going to take this data and we're going to put it in this stem and leaf plot. And these are heights of basketball players in inches. Now here's how it works. The stem of your stem and leaf plot is going to be, in this case, it's going to be your tens place. If you have if these were in the hundreds, then your stem would be the tens and the hundreds. If this were decimal, like 8.2, 8.1, or whatever, your stem would be the ones place, and then the leaves would be in the tenths place. But we're starting with something really basic like this. So the tens place for these, the smallest tens place that I see in this set of data, so I have 80s, 70s, 80s, 70s, 80s, 60s, 60s. So 6 is the smallest tens place that I see here. And I have some numbers that are in the 70s, so 7 is my next stem, and I have numbers in the 80s, so 8 is my next stem, and I don't have any numbers that are in the 90s, so those are my only stems. Now the leaves are going to be the ones place, and you're going to write down a leaf for every number that you see. So there's one number in the 60s. I'm going to cross it out. It's 69, so the leaf is going to be 9. I'm crossing these out so that I can keep track of them. So now I'm going to write all the numbers that are in the 70s. So I have 79, 74, I have 70, so that's definitely going to be the smallest. My leaf for 70 is going to be 0. Do I have any 70s? Do I have any 71s? Nope, I have a 72. So my next leaf is going to be 2. Do I have any more 72s? Nope. 73s? Nope, 74. I have a 74 here. So my next leaf is going to be 4. And do I have any more 74s? Nope. 75s? No, I have a 76. So my next leaf is 6. I have another 76, so I'm going to put another 6. You put one leaf for every number, for every instance that it shows up. I don't see any more 76s or 77s. I have a 78, so my next leaf is an 8. No more 78s. I have a 79, so my next leaf is a 9. I have another 79, so this leaf is a 9, and another 79, and so one more 9, one more leaf. Okay, I'm left with my 80s now. I have 80, so that leaf for the stem of 8 is going to be 0. I have an 81, so my next leaf is 1. I have an 82, so my next leaf is 2. Another 82, so that's another leaf, that's 2. And another 2. Another 82, so I put another leaf that is number 2, and then I have an 84 for my next leaf is 4. So that's my data. Now I always need to put a title so I know what all this information is supposed to be. Otherwise, it's just a bunch of random numbers. So I'm going to put. I'm just going to name it the same as my data table: heights of basketball players in inches. And that's my title. Maybe I'll make it more flashy. Anyway, so on the bottom, what you'll see is on the bottom you'll see 6/9 represents, and then a blank. So here's what you put in that blank. You want to know that you want to make it clear that the 6 is the tens place of the number. It's not the ones place. These are not tenths place. This is not the hundreds place, and these are not ones or tens place. 6/9 represents 69. Now, if my numbers were decimals, I had 8.2, 8.1, and all that. My stem and leaf plot would look exactly the same, but the key would be different. I would say 6/9 represents 6.9. So that's how you interpret what place value these numbers are in. So that's how you make a stem and leaf plot. Now we're going to analyze one. So here's a stem and leaf plot of daily high temperatures. So we're going to find the range of these temperatures. It's going to be the greatest temperature minus the lowest temperature. So the greatest temperature is going to be the biggest number. So my biggest stem is 9, and the biggest leaf of that stem is 8. So my greatest temperature is 98. And my least temperature is going to be my lowest stem with my lowest leaf. That's 64. So this is very easy to navigate or understand these numbers when they're in this format. This is a very good organizational tool. So now we subtract them. 98 minus 64. And if I were to subtract these, I would get 34 degrees Fahrenheit. So my range is 34. So how many more days was the high temperature in the 80s than in the 90s? Well, let's see how many days we had a temperature in the 80s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I had 10 days in which the temperatures were in the 80s. And how many days was it in the 90s? 1, 2, 3, 4, 5, 6, 7. 7 days. For 7 days, it was in the 90s. So I subtract these, and I get 3 days. It was very easy to do that because it's organized very well in this stem and leaf plot. So now the next question is, what were the temperatures on the days when it was less than 80 degrees? So days that were less than 80 degrees are everything that is in this box here, because the stems are 6 and 7. So I know these are all under 80 degrees. So I have 64 degrees. I'm going to type this a little easier. I have 64 degrees, 68 degrees, 68 degrees again, 74 degrees, and 75 degrees. And it was very easy for me to write those down or to come up with those because I was just reading it off the chart. 64, 68, 68, 74, and 75. And that is a stem and leaf plot.